Hello everyone, this is K.Hari Babu, working as Associate Professor of ECE Department in MLR Institute of Technology. Today we are going to discuss about probability theory and stochastic process. In that one, first we need to discuss about probability theory. So the topics are deterministic and a non-deterministic signal, set theory, sample space, events, relative frequency and axioms of the probability, joint probability and conditional probability, total probability theorem and Bayes theorem. So now first we need to discuss about what is meant by deterministic signal and non-deterministic signal. Deterministic signal means a signal whose future values can be predicted with the help of definite relationship is called deterministic signal. For example, x of t is equal to 2t square plus 3t plus 1. Assume this is the relation between the equation. In this case, I want to find the signal value at t equal to 0. That is, x of 0 equal to 2 into 0 square plus 3 into 0 plus 1. So answer is 1. Always for this equation at t equal to 0, 1 only. Today or tomorrow or day after tomorrow, whatever may be, the signal answer may get same value only. So this is deterministic signal. Next, what is meant by non-deterministic signal? A signal whose future values cannot be predicted is called non-deterministic signal. Means here I can't predict the signal for this one. If we can't predict the signal means that is called as random signal. Random signal means the signal values are varying along with the time and frequency. So now the probability theory attempts to work on this type of non-deterministic signal to found statistical properties such as mean, variance, autocorrelation, cross-correlation, etc. Why we are using this one means by using these type of properties, we can design analog and digital communication systems. So this is the use of non-deterministic signal to find this one. So next, set theory. First of all, what is meant by set? Set is a collection of well-defined elements. So for example, generally X is the set. The elements of set is represented by small letters, that is x1, x2, x3, so on, xn. So here there are different types of sets are there. First one is empty set. Empty set means if the set having null values, called empty set, or there is no value. Generally it is represented by x equal to 5. 5 means there is no element or null element. Finite set. If the set having finite number of elements is called finite set, that is x equal to 1, 2, 3, 4. Here, see here, we are using only finite number of values only, limited number of values only. So this is the finite set. Here we can define infinite set also. That is, if the set having infinite number of values, then it is called infinite set. That is x equal to 1, 2, 3, 4, so on. Infinite values. So next, subset. For example, A, B are two sets. Here, A is subset of B, means every element of A must be in the elements in the B. Then it is called subset. For example, A equal to 1, 2, 3 and B equal to 1, 2, 3, 4, 5, 6. Assume this one. See here, every element of set A must be in B. Then it is subset, that is represented by A is subset of B. Next, what is meant by disjoint set? It is also called as mutually exclusive set. Means, for example, A comma B are two sets. These two sets are mutually exclusive, means there is no common element between these two sets. No common element. For example, A will be taken as odd number elements, and B is assumed to be even number elements. See here, odd number element, even number element. In this case, there is no common between A and B. So, this type of sets are called disjoint sets or mutually exclusive sets. Next one, universal set. So here, set of all the possible outcomes of the system is called universal set. Example, tossing a coin. So here, tossing a coin means the sample space will be taken as head comma tail only. See here, the universal set means for this tossing of coin, we are getting two values only, h comma t only. Otherwise, another example, throwing a die. So here, sample space 1, 2, 3, 4, 5, 6. So these are the example for universal set. Next one, sample space. So here, for example, I am conducting one experiment. For this experiment, set of all the possible outcomes is called sample space. Example, tossing a coin. Tossing a coin means that is sample space having head comma tail only. Similarly, throwing a die. That is sample space having 1, 2, 3, 4, 5, 6 elements. So that is the sample space. Generally, this sample space is also classified into two types. That is continuous sample space, discrete sample space. What is meant by continuous sample space? Here, the set of all the possible outcomes within the given range is called continuous sample space. See here, for example, I am assuming my x value is varying between 0 to 1. So here, from 0 to 1, infinite number of values are there. So this is called as continuous sample space. Next one, discrete sample space. That is, if the sample space having discrete and finite number of elements, that is called as discrete sample space. Example, s equal to 1, 2, 3, 4. This is the finite number of elements and this is called as sample space. We can define discrete with infinite number of also. That is, that sample space is represented as s equal to 1, 2, 3, 4, 5, so on like that. Infinite number of elements are there, but all these elements are discrete nature only. So this is the discrete sample space. So next, event. Event is defined as set of possible outcomes of the experiment is called event. Set of possible outcomes. See here, already we know sample space. Event also same, but here event is subset of sample space. Why? Because see one small example. Deck of 52 cards. I want to draw spade card. Here 52 card means generally we can write sample space will be written as I can write 4 varieties of cards. That is spade card, club card, diamond card, heart card. These are the 4 varieties of cards. Each cards having 2 to 10 number and J, Q, K, A. So here generally first we should know what are the varieties of the cards means. For example, diamond. So this is the diamond shape. So this is the heart shape. Generally these two are red color. And spade. This is the spade and club. So these two are the black color. Now he is asking, I want to draw the spade color. Out of 52 cards, I want to draw the spade card. How many number of spade cards are there? Only. So means 13 cards are spade cards. So this is called as event. Simply, event is the subset of sample space. So next, relative frequency and axioms of probability. First of all, we should know probability introduced through relative frequency. First of all, I need to assume sample space S. On this sample space, I am assuming event A. Now, I want to find the probability of event A. So that is my assumption. So now I need to define probability introduced through relative frequency. So here, for example, if the experiment is repeated n times, out of n times, my event A occurs n of A times, then the probability of event A is relative frequency of event A when n tends to infinity. That is, probability of event A, P of A is equal to limit n tends to infinity, n of A by n. This is the definition of probability. Next, axioms. Relative frequency through axioms. So means we know already what is meant by probability. Now we need to know axioms, means we need to define the rules. Already we are discussed about the sample spaces having event A. The probability of event A is represented as P of A. Now we are continuing that one. First one, that is axiom 1. So here always the probability of event A must be greater than or equal to 0. This is the first axiom. Always probability must be greater than 0 and less than 1 only. Next, second axiom. So that is always the probability of sample space must be equal to 1 and probability of null must be equal to 0. That is the axiom 2. Next, third one, axiom 3. Here, I am assuming n mutually exclusive events, that is B1, B2, B3, so on, Bn. All these elements are mutually exclusive. So simply I can write B1 union B2 union B3 union so on Bn is equal to sample space only. So that is, simply we can write B1 union B2 union B3 union so on Bn is also written as B1 plus B2 plus B3 plus so on Bn is also equal to sample space. Why? Because we are telling n mutually exclusive events means there is no common between any two elements. So simply I can write union is also equal to summation. So simply we can write union of n equal to 1 to n, Bn is equal to summation of n equal to 1 to n, Bn. Both are same. So this is the third axiom. Now we need to discuss about joint probability and conditional probability. So what is meant by joint probability? Joint probability means consider two probabilities or two events. Here those two are not mutually exclusive, means common elements are there, then these two events jointly occurring or simultaneously occurring is called joint probability. Otherwise, for example, if the event is repeating n times, that is experiment, here event A comma B occurring n of A times, n of AB times, then the joint probability is represented as P of A intersection B is equal to limit n tends to infinity n of AB by n. So this is the joint probability. Similarly, we need to discuss about conditional probability. Here also, if the experiment is repeating n times, out of n times, event A occurs n of A times and event B occurs n of B times, and event A and B jointly occurring n of AB times, then the conditional probability is defined as the relative frequency of joint occurrence event n of AB with respect to n of B. That is, simply we can write P of A by B is equal to limit n tends to infinity n of AB by n of B. So here P of A by B is equal to limit n tends to infinity, we can write n of AB by n divided by n of B by n. So here already we know that this limit n tends to infinity n of AB by n is also written as joint probability. So we can write P of A intersection B divided by n of B by A n, we can write P of A. So simply we can write P of A by B equal to P of A intersection B divided by P of A. So this is the conditional probability. Now we need to discuss one small problem related to this joint probability and individual probability. See here what he is giving. Single card is drawn from a 52 card deck. So total cards are 52, n equal to 52. Okay. Next, what he is asking, first bit is, what is the probability that the card is a jock card? First of all, we should know cards data, information about the cards. See here, diamond, heart, spade, club. These are the four varieties of cards. Each one contains 2, 3, 4, 5, 6, 7, 8, 9, 10, jock, queen, king, ace. All these varieties contains these 13 number of cards. So now what he is asking, first bit, I want to draw the jock card only. I want to find jock card probability. So see here, diamond contain jock, heart contain one jock, spade contain one jock, and club also contain one jock. Out of 52 cards, 4 cards are jock cards. So simply I can write 4 by 52. Out of 52, 4 cards are jock cards. Now what he is asking, next one, the card will be, drawing card will be 5 or smaller. That is, I want to find P of X is less than or equal to 5. See here, in the diamond 2, 3, 4, 5 up to this one. Why? Because these are the less than or equal to 5 only. Similarly, this heart also contains 2, 3, 4, 5. This spade also contains 2, 3, 4, 5. This club also contains 2, 3, 4, 5 cards. See here, total cards are 16 cards, 4 plus 4 plus 4 plus 4. Out of 52, 5 or smaller cards are 16 cards, that is 16 by 52. Next one, the card will be red card. I want to find red card only, red card probability. See here, how many red cards are there? First of all, diamond and heart, these two are red color only. Now, I want to find the red color card. Total 26 cards are there with red with 10. So here total 26 cards are there. Out of 26, how many 10s are there? 2 10s are there. So now I am finding joint probability, combining event. In these cases, 2 10s are there. So means simply we can write 2 out of 52. So this is the problem related to individual probability and joint probability. So next problem is related to individual probability, joint probability and conditional probability. See the given data. Here I am using 100 number of resistors and tolerance values also given in the table. Let a resistor be selected from a box and assume that each resistor has same likelihood of being chosen. Define 3 events. What are those? First one is drawing a 47 ohm resistor. Second one, 5% tolerance. Third one, draw the 100 ohm resistor. These are the 3 events are given. Now, I need to find individual probability, joint probability and conditional probability. First, we need to find the joint individual probability. See here, I want to find probability of event A, individual probability. See here what he is asking, draw 47 ohm resistor. See here, this is the 47 ohm resistor. The total 47 ohm resistors are 44 are there. Out of 44, that is out of 100, 44 resistors are 47 ohm resistors. Means simply we can write 44 by 100. Next one, I want to find the probability of 5% tolerance. That is event B means we can write probability of B is equal to, see here, out of 100 resistors, how many 5% tolerance are there? See here total number are 62 are 5% tolerance. So, out of 100 resistors, 62 are 5% tolerance. Next one, I want to find, draw the 100 ohm resistor, that is P of C, 100 ohm resistor. So, finding the probability for 100 ohm resistor, that is, here 100 ohm resistor means out of 100 resistors, 32 are 100 ohm resistors. Now, we can write probability of 100 ohm resistors means out of 100, 32 are 100 ohm resistors. So, this is the individual probability. Next, I want to find joint probability. So, means we can find probability of A intersection B. Okay. So, means P of A intersection B. Now, what is meant by A? What is meant by B? A is drawing the 47 ohm resistor. Event B is 5% tolerance. Now, I need to find the common between 47 with 5% tolerance. See here, 47 ohm resistors are 28 are 5% tolerance, 16 are 10% tolerance, 44 are total resistors. Now, what he is asking, another condition, 5% tolerance only. Now, the common between 47 with 5% are 28 out of 100. Now, I can write 28 by 100. Okay. Next one, I want to find the probability of B intersection C. Means I need to find the common between drawing the 5% tolerance and 100 ohm resistors. See here, 5% tolerance means these are the 5% tolerance resistors and 100 ohm resistors are 24 or 5%, 8 or 10%, total 32. Now, out of 100 resistors, I need to find the common between 100 with 5% means 24 are common between 5% and 100 ohm resistors. Next, I want to find P of C intersection A. Now I need to find the common elements between 47 ohm resistor and 100 ohm resistors. See here, these two are two mutually exclusive events. There is no common between these two events. That's why simply P of A intersection C or C intersection A is 0. Now we discussed about the joint probability. Now we need to discuss about conditional probability. Conditional. I want to find P of A by B. Find the probability of A given B is written as P of A intersection B divided by P of B. See here, I know already P of A intersection B value, that is 28 by 100 divided by P of B means 62 by 100. That is first one. Next, I want to find the probability of B by C. So, we know already conditional probability definition. By using that one, we can write P of B intersection C divided by P of C. That also equal to 24 by 100 divided by 32 by 100. Next one, P of A by C. That also equal to P of A intersection C divided by P of C. So here, already we know P of A intersection C. There is no common between those two means simply 0. So this is the conditional probability. That is, till now we know about individual probability, joint probability and conditional probability. So today's section is completed. Next we will discuss next time, that is total probability theorem and base theorem. Thank you.